Alright, hello everyone. So welcome to my new trigonometric substitution video. So in this video I'm going to help you, I'm going to teach you how to integrate a function like this using trigonometric substitution. Now you might ask, well, we have been solving a lot of trigonometric substitution problems, so what's the difference? Well, all the problems that we solved so far look like this. That means you might have x square plus 9 or x square minus 9 or 9 minus x square. So what's the point? You had only two terms inside the square root. X square term and the number, right? But look at this problem. We have three terms, right? X square, 6x and 30. Now we didn't have that x term, x to the power 1 term in previous problems. How can we deal with this? Well, can we just go with like traditional method, like the substitution here is x is equal to square root 13 tangent theta? No, it doesn't work here. We have to find something new. We have to use a trick to solve these problems, especially when you have three terms. That means a full quadratic function inside this square root. Now what can we do? Well, I just mentioned you that if we have only two terms inside the square root, then we are much more comfortable, right? At least we have seen how to solve those type of problems. Now what I'm going to do here in this video is I'm going to rewrite this problem look like this. So what's the difference? So here you can see there's only two terms inside the square root. I know still that x plus 3 squared looks weird, but trust me, it's okay when you start using trigonometric substitution. So it boils down to two questions. How can we convert this given function to look like into something like this? That means given three terms inside the square root, how can I get two terms? And then once you get two terms, how are you going to proceed from there? What are you going to do from there? How do you do trigonometric substitution? So two questions. So in this video, I'm only going to answer the first question, how to rewrite the quadratic function, okay? The second one, well, I will save it for another video. So the process to rewrite this quadratic function in this way, that's called completing the square. Okay, so basically I'm going to review completing the square in this video. Okay, so to understand this, let's look at these three special quadratic functions. Okay, alright, x plus 3 square is actually x square plus 6x plus 9. How did I get that? Well, I multiplied x plus 3 by x plus 3. That's the meaning of x plus 3 times x plus 3, right? I mean x plus 3 square, right? So x plus 4 square is x square plus 8x plus 16. So similarly, we can get. So I expand what you have in the left hand side. Perfect. Now can you see a relationship between this number here and here and here? Relationship between 4, 8 and 16. Relationship between 5, 10 and 25. Do you see something? Well, first let's look at the last number. 9 and 3. What is the connection? 3 square is 9, right? What is the connection with 4 and 16? 4 square is 16. 5 square is 25, right? So you can see there's a clear connection, right? Number here gets squared and that's the single number here on the right hand side. Okay, what is the connection between 3, 6, 4, 8 and 5, 10? What do you think? It's twice, right? Twice of 3 is 6, twice of 4 is 8, twice of 5 is 10. So the middle number or the coefficient of the x term is twice of the term here. Alright? Okay. So what does this mean? Let's go back to our original function, x square plus 6x plus 13. So let's write it down, x square plus 6x plus 30. Okay, now what I'm going to do is I'm going to rewrite this function like something that you have in the left hand side. So the relationship it is actually, if you look at 6 here, okay, so we know it should be half. Okay, so this should be x plus 3, right? Because the relationship that we saw here is 4, 8, 5, 10, right? Twice relationship, right? 3, 6. But does that work here? No, right? These two are not the same because x plus 3 square is x square plus 6x plus 9. Here you have 13. So that little trick or that little thing that we found didn't work here, right? Doesn't work here. So what can we do? Well, x plus 3 square is almost x square plus 6x plus 13. How off is x plus 3 square to become this function? Well, we know x plus 3 square is x square plus 6x plus 9. So how off it is? It's off by 4, right? So let's add a 4 here. So what do I mean? So x square plus 6x plus 13 is actually what? X plus 3 square plus an additional 4, right? So then from here you get x square plus 6x plus 9, and with that 4 you get x square plus 6x plus 13. So what's the point? So the point is you cannot write every quadratic function as a square of a single function like this, but we can write it as sum of two terms, okay? But by just looking at the middle middle coefficient or coefficient of x of the quadratic function, okay? That's the gist of it. So let me show you how to do it properly. Let's take x square plus 8x plus 2. So what's the thought process? Look at the coefficient of x, it's 8. Think about its half is 4. So this should be almost equal to x plus 4 square. Right, now what is x plus 4 square? X square plus 8x plus 16. So you have to do that multiplication by yourself, okay? So here this is 16. This will give you 16 as the last number, but you have 2 here. How can you make 2 out of 16? What do you think? Subtract how much? 14. So not only you can add, you can subtract 2. So this will give you x square plus 8x plus 16 minus 14. With this minus 14 will give you this function, right? That's the gist. Okay, so let me show you another example. X square plus 8x plus 25. So the middle number is 8 divided by 2, that's 4. So x plus 4 square, and x plus 4 square is, we know, x square plus 8x plus 16, but you have 25 here. How off this guy from the function you have on the left? 9, right? So 16 plus 9 is 25, so you're off by 9. So add a 9. Let's look at another one. Alright, x square plus 4x plus 12. Okay, so you look at 4, coefficient of x divided by 2, that's 2. So x plus 2 square. What is x plus 2 square? X square plus 4x plus 4. So we have 4 here, so you have to create 12. How off it is? So 4 plus 8 is 12, right? So you add another 8. Okay, alright, so let's think about x square plus 4x minus 3. So look at 4, its half is 2, so this is x plus 2 square, just like this example. So you need minus 3 here, you have 4 here. So to get minus 3 out of 4, how off it is? So you have to subtract, right? How much you have to subtract? 4 minus 7 is minus 3, right? So you subtract 7, you subtract 7, so 4 minus 7 is negative 3. That's how you do it. So what does this mean? Well, now when you have x square plus 6x plus 13, now think about this. So 6 divided by 2 is 3, so it's x plus 3 square. X plus 3 square, you will get x square plus 6x plus 9, but you have 13 here, you need 4 more, so plus 4. That is how I get this term inside the square root using the function inside the square root in the original problem. So this is called the completing the square. Okay, now here's the thing. In this video I only taught you how to convert or how to rewrite the function in a different way. When you are given 3 terms, when you are given a full quadratic function inside the square root, you rewrite it so that you can get 2 terms, okay, by using the completing the square method. One more thing before we finish off this video, you have to be very careful. There's a one rule. So to do this completing the square method, you have to make sure the coefficient of x square term as 1. Okay, you should have coefficient of x square term as 1. If it is not 1, if it is like 2, 3 or negative 3 or negative 1 something else, we have to do another little trick that I will show you from another example in a different video, okay, when I'm solving actual full trigonometric substitution problem, because it's not that a big trick. Okay, so I have taught you the essence of it. I have reviewed the basic stuff, basic idea of completing this square, so you shouldn't have any problem. Okay, all right, so in the next video what I'm going to teach you is, okay, now we rewrote this function in a different way. Now how can we integrate, how can we use trigonometric substitution from here? Okay, I'll see you in that next video. Thank you very much. Bye bye.